So again, thanks again for joining us. And my name is Priyanka. I'm an engineer at DataTorrent. And joining us on webinar is Ajay Gupta. He is the presenter for today. He is a committer with Apache Apex project, and also he's an engineer at DataTorrent. So I'll just go through some logistics about our webinar today before we start. So the webinar is being recorded. So in case if you want to see it again, or if you want to share with some of your colleagues who could not attend today, you will get a recording after session is over. We are also going to upload the slides on the SlideShare for your future reference. In case if you have any questions, please submit them via question answer section on the GoToWebinar. We will take them during the logical breaks, or we can even reply over the chat as appropriate. Without doing any further delays, I'll hand it over to the Ajay.
Thanks, Priyanka. Hello, everyone. So good morning. Let us start with our presentation regarding how we would be debugging, how we can debug Apex applications using DataTorrent RTS. So, okay. So the agenda for today would be as follows. We would first start with an introduction to how Apex works. Post that, we'll be seeing how we use DataTorrent for debugging of Apex applications, and then we would conclude with we would conclude the presentation, and we would be open to questions. We would also be taking logical breaks where you can ask your questions. Okay, so about Apache Apex. So Apex is an basically Apache Apex is an in-memory distributed streaming platform. So it is Hadoop native, and so basically what we have is there are kind of logical operations which are written in code segments called as operators, and each of these operators basically connect to each other, and this is how the application basically flows. So each of these operators or code segments run in a distributed fashion in the cluster, and basically your application logic is written using these operators. So the application Apex provides an extremely natural programming model for basically it makes use of Java, provides Java API to express your logic. So there are we have a library called Malar which already provides a lot of operators, and if there is and if required, we can also write our custom operators. Apart from that, it also provides maintaining of states and as well as your metrics, so that your operators can maintain the state during the lifetime of your application. The applications written using Apex are highly scalable. They have a high throughput and low latency. So basically, when your application, the amount of data which is coming to your application increases or decreases, the application can itself scale on your cluster, and based on the amount of data coming, and so that it ensures that your SLA does not get breached. So basically, this means that it can actually scale dynamically depending on the load on your application. Then Apex, the applications written in Apex are fault tolerant. So we guarantee that even if one of your even if the nodes go down, or if the operators for some reason fails, we ensure that the operator automatically comes back up and starts from a committed position, checkpointed position, and this ensures that by ensuring that we preserve the state, we ensure that all the data which is coming to our application is processed at least once, and we can also guarantee end-to-end exactly once for our applications. Apart from that, Apex is the operability feature it provides. Basically, this means that we provide support for system and application level metrics to and this metrics can be used to record and visualize the application, so that we can actually monitor our application very easily. As a company, DataTorrent, what is our vision? What we see is currently is that big data is not yet completely productized, and not so it is extremely difficult to write big data applications, and it's difficult to monitor them as well. So what we as a company want to do is that we want to make this extremely easy. So what we mean by that is that the time to develop an application, the time to launch an application, as well as the cost after launching the application on your production, we want to minimize that for our customers. So this is what is the aim of our company. Um, what we want is that we want to provide a mechanism by which the applications built can be easily debugged. We can easily debug them. We are able to make use of existing pre-built applications as well. We want to provide support test for the uh, for the prod environments so that the applications can be launched quickly, as well as uh, we want the product should be able to manage, and basically the applications should be easy to manage and visualize so that we can easily monitor them. Okay. So what are the next gen applications? Basically, what are the so what we generally have is that we have a source which is providing all the data. So something like IoT or Kafka, or files which are generated um, in real time, or social media, something like tweets and all. We have a variety of things like HDFS or Kafka or databases. So we would like to process all of this data which is coming as input in real time, and write it to a store, so that probably later we may want to process it, or probably get some useful insights. But in real time also, we would also like to get some useful insights which can be easily done using Apache Apex and DataTorrent. Yeah. So apart from that, we uh, 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 as much as we provide support for streaming, so batch support is also provided, because batch, if we consider, it is actually only a subset of streaming. Okay. So like I said, we have a variety of data sources over here, like sensor data or social media. Um, then we have different other ecosystems like Amazon S3, Kafka, Solace, and so from all of these sources, we this is where DataTorrent fits in, wherein from the data sources, the data comes to Apex, and where we write our application using these operators. We process data over here, and then post that we can do some real-time analytics and visualizations, as well as ingest the data into other systems like HDFS or databases like Oracle and Cassandra. So this is the technology stack of our product. So this is the big data infrastructure. Over here is the basically it is the Hadoop installation on your cluster. So over that we have the Apache Apex code. This is the core engine platform which runs the which handles the application. Above that, we have a list of high-level APIs and uh, the Apex Malhar library. So Apex Malhar library is basically it is a library containing a list of pre-built operators, the generally used operators for example, for files, for reading files, or for reading data from databases from Kafka and other stuff. We have support for ML operators, for SQL operators, for some analytics operators, for transformations like reading from CSV files or JSON files, and many other stuff, as well as writing to many of these systems as well. So using these operators, as well as if required, by making use of high-level API for building operators, we can write our own application. So about this, since we want to make it easier for our customers, we have also provided a few built-in a few application templates, wherein you can actually see the code as well, and you can simply launch the application just by configuring some of the properties.
Just a minute. Someone is saying there is no sound.
Okay.
Can you check with everyone if they face the same problem or it's just one of them?
Okay. So can just anyone confirm if you can hear me or not by raising your hand or something?
I think others can hear you. So maybe Kazim, you might want to check your connection. I think others can hear you.
Okay.
Okay.
Okay. Thanks a lot.
Thanks for your feedback.
Okay. So yeah, regarding application templates, so these are pre-built applications which have been provided, and you can easily make use of these to, for example, for syncing of files or for transferring data from Kafka to HDFS, performing some transformations in between. So these makes it a lot easier if you so that you just need to make some small changes and you can you have your application ready. Above that, we have the DataTorrent stack. So this is the this is where DataTorrent comes in, and what we provide over here is real-time visualizations of data. Basically, we provide support for dashboards wherein you can monitor your applications as well as to ensure that everything is working fine, and monitor some of the metrics which your application would require. Then apart from that, we have basically you can easily build your application with ETL, and it provides a very easy mechanism to debug your applications. So how are basically applications kind of built in Apex, right? So we have a concept of operators and we have an concept of streams. So between two operators, the data is transferred by means of stream. So if we also actually see, we see multiple instances of operators. So this means that the same operator is replicated on different nodes in a cluster to ensure parallelism. So this will increase the basically the processing speed of your data. Yeah. So also, so we have so this is how we so basically we write operators, we define our operators, then we connect the operators using streams, and so over here we have an input operator, and over here we have an output operator, and you build your application as a kind of a directed cyclic graph, and we simply submit the application, and yeah, then the application will simply run. Okay, so how does Apex integrate with Hadoop? So let's assume that we have a 4-node cluster over here, and so assume that we have a resource manager running, and yeah, so now if we see, we have by means of Apex CLI, we can submit the Apex application to the resource manager. So once the application is submitted, the resource manager, the application will request the resource manager for some containers. So in this case, suppose that our Apex application had requested for 5 containers. So over here we have 5 containers. So this STRAM is the streaming application master. So this actually makes request to the resource managers that it requires 5 containers for deploying our application. So once the resource manager provides the requested resources, the application can start. So the STRAM then deploys these operators to different containers it has received, and then the application can start. So if we see over here, it has allocated a container 1 on the operator 1 on this node, then operator 2 on this node, and so operator 3 and 5 have got deployed on this node 3, and the operator 4 and 6 over here are actually, if you see, these are actually in the same process. So Apex does provide support for having multiple operators in a single process as well. Then apart from that, if you see, we have some MapReduce. So this simply means that we can actually also run other jobs like MapReduce on the cluster without impacting the Apex application. Okay, so regarding, let's now move to, okay, so first we'll wait for a few questions if we have any.
So I don't think we have any big questions as of now. We had a couple of them, but we replied them in chats. So we can continue with our debug session.
Okay. So considering that the application is now is getting deployed on a distributed environment, so monitoring all of these applications can become complex, right? So this is where the DataTorrent product comes in, and now let's proceed to how we can debug the Apex applications. So let's first start with the product overview, how DataTorrent the product looks. So so this is actually how when you install DataTorrent, so you can actually download the DataTorrent RTS from the DataTorrent website, and when you install it, this is how you can actually install it on any node on your cluster, and you can view it using your normal web browser. So when you open the website, this is the web page you will see. So there are a few. So if you see over here, we have the app hub page. So this is the one which I was talking about, the application templates and some of the pre-built applications which are there. So I guess my connection is a bit weak. So okay, yeah. So if you see, these are some of the applications like Kafka to database sync, and so you can simply import these applications, and you can actually then see the what these applications are doing. So over here we have also provided the description about how the application looks, and a video on how to run the application, the logical plan basically, which indicates what the application operates. So these are the different operators which have been used for building this application. These operators are already pre-built in the Malhar library, and then how we can configure the application for our cluster or for our environment, and then we can simply launch the application. Then we have the launch tab over here. So this is what we use for uploading the packages and as well as launching the application. So if you actually want to upload a package, we can simply choose the application which we have built and simply select it, and then we can simply upload it. So these were some of the applications which are uploaded. So on my cluster. This tab is used for monitoring the application, the monitor tab, and we'll come to this one in some time. The develop tab over here is basically for so basically we can upload the package as well as we can configure the applications which have been uploaded over here. So if we suppose that if you have a test environment and a prod environment, and if you would like to actually configure, create a configuration for both of these environments, you can simply create a new configuration and uh, mm, and then you can simply I'm having some issues. Then you can simply basically save the application, and this visualize tab is for actually for you can actually visualize the uh, some of the dashboards. So for example, I have actually already opened over here. So this was a visualization which was created uh, by one of my colleagues. So if you see, we have different visualizations wherein, so this can be built using the operators by Apex, and DataTorrent provides a mechanism to read the data and provide these dashboards. So we have many different dashboards for these. Moving on to the monitor tab. So this is where we make use of, this is where we can actually monitor the applications which we are running. So if you see, we have, it shows the information about the cluster, the amount of memory being used, and the peak allocated memory, the number of applications which are currently running, which have been killed, and the number of containers, the number of operators which are being used, the number of tuples which are getting processed per second across the entire cluster. So, so if we see some, let's see some application. So if you actually see, so we have multiple different tabs over here. So this is the logical view. So the logical view basically provides a logical description of how your application is. So if you actually see over here, this is the how you would actually build. This is your logic of how you would build your application. But so this is your application tag over here, and wherein we have multiple different operators, and each of these operators is performing some operation, and if required, we may actually have some partitioning over here. So for example, yeah, we show an example for showing the partitioning. Let me just check here. Okay. So yeah, so if you actually see something over here, we are reading actually over here from Kafka. So what we have done is that in the physical, if we see, we have six different operators, and wherein, but if you actually check the logical view, we would have okay, I guess okay, yeah, I guess this is a better example to show. So if you actually see, we have after this tag service geolocations, we have a store tag geolocations. But if you actually see now the physical tag view, we can actually see that we have multiple instances of store tag service geolocations. So this implies that each of these operators has got replicated on different nodes, and it is receiving data from the earlier operator. So yeah. So apart from that, in the logical view, we have we can see the number of operators, the latency for the application, the number of records which are getting processed per second across the application, uh, the total number of records which have been processed till now. Apart from that, we have support for shutting down that. So for example, if for some reason you want to update your application, you can simply shut down your application and restart it from that state itself. The kill will simply kill the application and it cannot be restarted. Then we can also set the logging levels for, so for example, if you would like to monitor your applications at the debug level, or if you'd like to change your log level, so we can simply change it and the application would change this logging level at runtime. So you can choose the different logging levels over here. Then we have the application master log. So basically the application master is the one which is controlling the entire application. So you can view the application logs from here. And then this is for visualizing the dashboards, for creating the dashboards. So the STAM events tab over here is for viewing the different events which are occurring, the important events. So for example, the start of a container, the start of an operator, the start of different operators which are happening, and if some exception occurs, we can even view those during the lifetime of the application. So over here we have the logical tag view, and we can actually monitor many different parameters like the CPU, the window ID on which currently it is, then the total number of records which have been processed, the total number of records which have got emitted. So yeah, so if you see the it continuously updates itself with the same information. Then we have a tabular view of the logical operators, wherein we can monitor the amount of CPU, the window IDs, the last heartbeat. Basically, each operator, each container sends the heartbeat to the application master, and this is the information. So you can actually come to know whether some operator is whether some container is down or not. Then the amount of latency which is being observed across for the operators, the number of records which are getting processed per second, and the total number of records which are processed or then this tab gives information of the stream, the different streams which we have in the application, the different sources and the things for the streams. And then we have the metrics chart, which is providing some information like the number of tuples emitted or the number of tuples processed, and the latency across the application. Yeah, so if we then move to the physical view, basically, since this will provide the actual information of all the operators which are deployed. Basically, the actual number of operators which are deployed in our cluster. So we may have multiple instances of the same operator, and we can actually monitor them using these. So over here also we provide the actual at the physical level, and at the physical operator level, we can actually see the number of records processed and the latency being. So if we have a very high latency, we can actually understand that probably the operator is receiving a lot of data, and probably because of that it is getting delayed, or we can actually also view the skewness for that, because if we have two operator instances of the same operator, we can, and if we actually see that one of them is processing a lot of data and the other is processing very less data, we can actually understand that there is a lot of skew, and accordingly we can change our program, so that our application, so that the skewness is reduced. Then we have the containers, and this shows the garbage collection which is happening across the application. And so now if we can actually also see the container information as well. So for example, for this container, we can see that when is the garbage collection happening, and we can see the logs over here. The apex.log provides the logs. Yeah, so we can actually see these logs and all. And then we have Yeah. Apart from that, for the since container is a process which is running on the cluster, we can actually also take a stack test so that if we actually want to view some if the operator has got blocked for some reason, or for if there is a high latency, so probably we can make use of the stack trace to actually view where the application is stuck, and probably we can uh, debug that application. So for example, these are the different threads which are running for that container, and so we can see the entire stack trace for that over here. Yeah. So um, yeah, uh, this one shows the physical diag view basically. So in this case, the logical and the physical diag view is the same. Um, then we have um, a few metrics chart over here in this tab, and this one shows the application attempts. So which actually when Apex launches the application, we if for some reason the first attempt gets failed, it tries to launch the application again, and uh, so this basically shows the number of attempts which are made for launching the application. The maximum number of attempts is 2, after which the application restart is basically it doesn't start the application. Yeah. So apart from that, this if we have, we can okay, I will just okay. So let us see. So we have actually made some applications wherein we can demonstrate you the uh, some of how we can actually uh, debug an application. So let's start with an application which so for example, let's see so suppose that for some your operator has got blocked, right? So we would actually want to see how where it has got blocked. So if we actually launch the application, um, yeah, so the application has got launched, and so while it is being accepted, let us try and change the log level. So for example, we have let us make all files with com.DataTorrent to be at debug level, and we can save it. So this was a simple operator, and if you actually see now the if you actually see over here the number of records which are being emitted over here by this operator, but this so basically what this application is that it simply generates a few random numbers, and this one is simply counting those numbers. So if you actually see now this operator is continuously generating random numbers, but this the counter operator over here has got the number over here is not increasing. So probably this operator has got stuck, right? So how we can see it is that probably we can go to the counter operator, the container containing this uh, operator, and so if you see, we can actually take a we can view the logs over here, and then we can actually take a stack trace, and uh, uh, So yeah, so if you actually see, it has got stuck over here in the number counter at the process tab. So we can actually go to this line and actually debug and see what is happening over here. Apart from that, if you actually now see the log levels for this operator, um, so we can actually now also see the debug level logs over here, if you see. So yeah, for the DataTorrent application. So yeah. Uh, so yeah, so yeah, so if you actually now see the code for this application, so what we have is that so what we had done is for this application is that if there was a if we actually wanted to block the operator, so this was a boolean variable. If we actually wanted to block the operator, and after a certain window count, we would simply run into an infinite loop. And if we see now, uh, the uh, the operator would be completely basically it will simply run in this loop, and it was blocked. So yeah, so this is how if you actually see in the process, if you had actually seen the stack trace, we would actually have seen that in the process tab we were actually processing at we were actually stuck at this line, and we can actually monitor what was happening at this part of the code. So let us move to the next demonstration. So I will simply kill this application now. So yeah, let us now have a look at failing operator. Um so if your operator is failing for some reason, how we can have a look at it. Uh, yes. So while the application is getting launched, let us have a look at the code. So uh, for the failing operator, what we had done is that okay, yeah, just a second. Okay. So what the yeah, so our application has got accepted, and it is running now, and it should fail in a few seconds. Yeah, yeah. If you actually see now, we have the operator error which is getting showed. So we can actually view the log file here itself, and if you see, it actually takes us to the location of the error, and we can actually see that what was the actual error over here. So over here we had a logical error wherein there was some divide by zero error, and so we can actually view the with the stack trace. We also have the stack trace over here, and we can simply uh, view the code over here, view where the issue is. So if you see, it was in the random number generator at line 37. So so if you actually see, we have the random number generator here, and so at line 37 we were actually dividing by 0. Okay, so yeah, so if you actually now see, the operator is continuously getting redeployed. After the failure, the operator gets redeployed by the platform, and since it actually encounters the same error again, it is actually continuously failing. So we can actually see the entire what all is happening. So after encountering the operator error, we stop the random generator operator, and as well as we also stop the counter operator and the containers as well. And so if we see, we have stopped the yeah, and so once these operators are undeployed, we redeploy these operators again. So we start the container, and we start these operators as well. So yeah, so now let's move to the next application. So let us now first view the a latency application, wherein how we can actually debug latency issues with our application. So yeah, so now that the application has started, if we uh, yeah, so I just changed the log level of the application to debug, so that we can actually monitor as well. So if we now actually see the latency over here has increased, we can actually see that it is more than 1 second in the, it is continuously increasing. So what we can do over here is that we can go to the we can actually check from here which is the operator which is causing the issue. So if we see over here, we can actually see that the counter operator over here has a very high latency. We can actually now use actually check with this one. We can actually monitor the logs for this operator, and determine what is happening. So yeah, so we can actually view the logs as well as the stack trace as well to determine where we are actually getting stuck. So yeah, so if we actually see, these are the logs, and if we actually go and see the stack trace, let me just see the stack trace. So yeah, so if you actually see, yeah, so if you actually see, the IO over here is taking a lot of time because we are continuously writing a lot of data, and so this is how we can actually view that, see that. Um, Basically, it provides a very easy mechanism to actually view the stack traces and the logs, and we can easily monitor our the applications, the Apex applications. So yeah, let us now have a look at uh, another application so in case our application is memory intensive and is making and is actually generating a lot of data, and and if there is a lot of garbage collection, how can we actually view that? So let us have a look at that. I'll just kill this application. So yeah, let us launch the so while launching the application, we actually have an additional launch options wherein we can specify garbage collection logging. So this will actually enable garbage collection logging, wherein we can wherein whenever garbage collection happens, a log will be added to the garbage collection log file. So if we launch this application, so the application has got submitted, and yeah, so yeah, so now the application is running. So if you actually now see, so this is the operator where I was wherein we are actually uh, we can actually see what is happening. So this is a heap memory wherein we can actually see that there is a lot of memory which is getting allocated, and wherein the garbage collection is happening. So we can actually also go to the container and we can view the logs over here. So we have this garbage collection additional log which gets created, and we can actually see that there is a lot of garbage collection which is happening. So so there is a normal garbage collection as well as full garbage collection which is happening. So this actually will indicate to us that the application is spending a lot of time in doing garbage collection, and hence the application is probably running slow. And so we can actually have a look at we can actually fine tune our application so that the memory being used is memory being used by our application is optimal for the for the uh, cluster where our application is running. Yeah, so yes, that is it regarding the debugging. Yes. Yeah, so yeah, so we actually have a few blogs which are written, as well as you can actually have a look at the app hub web page and the app templates which we have at datatorrent.com, and the GitHub link for the app templates. Then these are the different resources wherein you can actually learn more about Apex and DataTorrent. Do join us for the meetups which keep happening, and the slides which will also be shared by the SlideShare, and the presentation will also be shared by YouTube, and we would also receive a mail regarding the same. If you would like to actually we actually also provide free enterprise license for startups, and if required, we do contact DataTorrent for the same. Thanks a lot. Do post your questions via the questions tab. We would be happy to answer them. So I guess there are no more questions. So do provide any follow-up questions if there are any on via. So we actually have a DT users Google groups, and you can always post your questions on that, as well as via the Apex mailing list. So yeah, so I guess we can conclude the session now. Thanks a lot for joining us. Have a good day. Thank you.
Marcus.